solenoid now, and in this solenoid, whenever there is a current changes, either the current is increasing in this solenoid or decreasing, then what happen? Automatically, there will be the current induced in this coil to oppose the increasing or decreasing current. If the current in this solenoid is increasing, okay, then current induced to decrease the increasing current. Okay, if this current is decreasing, then current induced to increase the current. Okay, so self inductance of solenoid we have discussed, and this is the formula for the coefficient of self inductance in the last class. And today we will discuss inductor. Today we will discuss the inductor. Like capacitor, we have na capacitor. There is another thing, inductor. Basically, inductor is a wire bounded in helical form. This is the inductor. Okay, this is the inductor. So it consists of number of turns of insulated wire, and it opposes the change in the current. It opposes the change in the current. Basically, what is the meaning of that? You have an insulated wire, and insulated wire, suppose this is a wire, okay, this is the insulated wire, and this is wounded like this, okay, like this. So exactly I cannot make, but try to just imagine. So this is the inductor, okay. So this consists number of turns of the insulated wire. This is one turn, second turn, third, fourth, five. Number of turns are there. If there is a change in the current in this inductor, then there will be the induced current in this inductor, and there will be the induced EMF also, and that induced EMF is given by minus L di by dt, minus L di by dt. Okay, so what is this E? Induced EMF in inductor. What is di by dt? Rate of change of current, means the current is changing with time. Okay, di by dt, current is changing with time, so you can write it rate of change of current. Rate of change of current you can write. So basically, inductor consists number of turns of insulated wire, and it opposes the change in the current. Suppose the current is increasing, so in this increasing, so this inductor will oppose that increasing current. Okay, induce a current in the opposite direction of increasing current. Okay, if the current is decreasing in the inductor, then the current will be automatically induced in this inductor to support the current, or you can say in the same direction of the current. So basically this formula you should know. This is the EMF induced in the inductor. E is equal to minus L di by dt. What is L? L is the coefficient of self inductance. L is coefficient of self inductance. So basically now we will see magnetic energy stored in the inductor. Magnetic energy stored in the inductor we will see. Okay, so I have already made the diagram and all that. So magnetic energy stored in the inductor. In the inductor. So this is your inductor. Okay, this is your inductor. And This inductor is connected with battery, but this time this circuit is open. This circuit is open this time. Initially, this is the open circuit, means at t is equal to 0. T is equal to 0 means initially circuit is open. So simple, you can say current is equal to 0. There will be no current. Okay, there will be no current, and you can say there will be no induced current. If there will be no current, then there will be no induced current. Okay, suppose after some time you have just closed this key, then what will happen? When you will close this key, then what will happen? This is the battery. Due to this battery, there will be the current. Obviously, there will be the current. So there will be the current in this inductor. Okay. And what happens now? When you just close the switch, na, when you will this initially the switch is opened, and after that you closes the switch. Okay. So just you have closes the switch, the current will start increasing from 0 to some value. Okay. So current in this circuit will start increasing from 0 to some value. Okay, now you have closed this switch, current start increasing in this circuit from 0 to some value, means you can say the current is start increasing in the inductor. And what happens when the current starts increasing or decreasing in the inductor? Induced current will be there. So there will be the induced current in the opposite direction of this current. Why? Why in the opposite direction? Because current is increasing. If the current is decreasing, then the direction of the induced current will be in the opposite direction. So basically, you have closes this switch, battery is connected, means circuit is complete. Now there will be the current, and this current is increasing from 0 to some value, so there will be the induced current in this inductor. Okay, and E is the EMF, capital E is the EMF of the battery or the cell. L is the self inductance. Okay. Okay, now I have told you, when there will be the current in the inductor, there will be the induced EMF in the inductor, that is given by E is equal to minus L di by dt. Okay, so this will be the induced EMF in this inductor, minus L di by dt. Okay, so induced EMF, I have told you that induced EMF will oppose the increase in current when switch is closed. Okay, this induced EMF will oppose the increase in current by inducing an induced current in the opposite direction. Okay, this is the current in the opposite direction of the given current. So in this case, what you have to do now, as the current is increasing in the inductor, there is an induced EMF in the inductor that induced EMF is opposing the increase in current. So what you have to do? You have to do some external. Not you have to do. This battery have to do some external work to increase the current, because this induced current or induced EMF is opposing the increase in current. So to maintain the current in the circuit, this battery have to do some work. Okay, that work will be stored as the magnetic energy in the inductor. So that work basically we have to calculate. Okay, so work done by the cell to change di current in the coil in time dt. So di and dt means, suppose for a small interval of time dt, there is a change in the current in the inductor di. As you have just closes the switch, the current will starts changing. So we are supposing for a small time dt, the change in current is I. Okay, and to change that current di in time dt, the work done is given by p into dt. What is p into dt? P is the power of the circuit, And what is power? Power is EMF into dt. Okay, power is voltage into time. Okay, so voltage is EMF here and dt is the small time. Okay, so this dw is power. dw is the work done, a small work done. Okay, a small work done in time dt to change the current di. Now this dw can be written as uh, this is a power na. Basically power is not this. There are three formulas of power. I have told you. P is equal to v square by r. Okay, P is equal to I square r. There is one more formula. P is equal to v into I. Okay, so what is v and I? V is the potential difference, or you can say EMF. So this power can be written as power. This power can be written as, I am using this formula. So V is E here, EMF into I. Okay, and this is dt. This is dt na. Now we know that this EMF of the cell, this EMF of the cell will be equal to the EMF induced by the inductor. Okay, this EMF, this total EMF will be here na. So this EMF induced will be equal to the EMF of the cell. So EMF of the cell is equal to minus E, and we know that the value of E, we know that the value of E, L di by dt. Why this is here? Why I have taken the minus sign? Because this opposes opposes the change in the current due to this battery. Okay, so we will put the value. So this is dw na. So we will put this value of E. So E is L di by dt. L di by dt into dt. This dt and dt will be cancelled out. So basically you have dw is equal to L into di. So this is the small work done. This is the small work done in time, in a small time dt to change the current di. But to change the total current, you have to do the integration. You have to do the integration. Okay. So work done by the cell to increase the current from 0 to I. So you will do the integration 0 to I L di by dt. Okay, you have integrated this equation. Okay, and you have applied the limit as the current is increasing in the circuit from 0 to I. Okay, now this will become W. This will become W, and this L is constant, so we can take this out of the integration. This is 0 to I. Okay, and this is I into di. Okay, so I have to tell you the integration here. If it is written as 0 to 5, okay, and here written as x into dx. So in that case, your integration will be, you will, this is x to the power 1 na, so you will increase one power this, here x square, and this 2 will be in the denominator, and here you will put the limit 0 to 5. Okay, so this is known as the upper limit, this is known as the lower limit. So accordingly you will put 5. Okay, minus you will put 0. So same is the case here. This is L, so integration of this will become I square by 2, and limit of integration is 0 to I, so it will become I, it will become, you will put this value of I here, so that it will become I square, and this will become 0 square, and 2 will be here. So basically you will have the total work done is equal to half L I square. This is the total work done you will get. And this total work done will be equal to the magnetic energy stored in the inductor. I have told you. Work done by the cell against uh, self-induction will get stored in the form of magnetic energy. So this your magnetic energy will be equal to the work done. You can say that your magnetic energy will be half Li square. Okay, your magnetic energy will be half Li square. So this is the formula for the magnetic energy stored in inductor. Magnetic energy stored in inductor. So basically what is happening here, initially the switch is open. Okay, you have closed the switch, current starts increasing, induced EMF in this, due to this induced EMF there will be the induced current, and that induced current will oppose this current. So to increase this current in the circuit, this cell have to do the external work, and that work will be stored in the inductor in the form of the magnetic energy. Okay, all of you note down. Okay, oh, you can note down now. So inductor, what is inductor? Inductor opposes the change in the current. Okay, change in the current. What is the work of inductor? In the inductor induces the EMF when the current changes in the inductor, and due to that EMF there will be the induced current in the inductor. Nafisa completed.
Yes, sir.
Matthew, Nawal
Give me a
completed.
second, sir. Give me a second.
Yes, sir.
Okay, no.
Yeah, so you can scroll down.
Okay, so write down this. Completed, Matthew and Nafisa?
Yes, sir.
Yes, sir.
So this formula, basically this formula is equal to minus L di by dt. This is the induced EMF in an inductor, and this is the magnetic energy stored in an inductor. You should know. Okay. So on this, I am taking one question. So in this question, they are saying an inductor have the inductance of okay, an inductor have the inductance of 10 Henry. Okay, 10 Henry inductance is given. This, what is this? This is L. Is connected to a variable supply. Is connected to a variable supply of 10 ampere. Okay, so variable supply of 10 ampere is there. So current is given here. Supply have the current of 10 ampere. Rate of change of current is given. See, rate change of current. Rate change of current means di by dt is given. Okay, di by dt is given. Now basically what we have to calculate, first part, induced EMF in an inductor. Induced EMF in an inductor is given by minus L di by dt. Okay, minus, what is L? L is 10, di by dt is 10. So this will become minus 100. This is what is this? This is EMF. So unit of EMF is volts. Now second, they are asking energy stored in an inductor. Energy is stored in an inductor. So what type of energy is stored in an inductor? Magnetic energy is stored in an inductor. So you will write this formula. Energy stored in an inductor is given by half Li square. So half L is 10. Current is also 10. 10 square. So this will become 5 and multiplied by 100, this will become 500. 500, unit of energy is joule. Unit of energy is joule. Okay. Now there is one more last topic, very easy topic. Okay. Energy density. Energy density. What is the meaning of energy density? We have done, or you have done that energy density for a capacitor. So basically the energy density means energy is stored per unit volume, means in unit volume how much amount of energy is stored, that is the energy density. Okay, so for inductor, suppose this is the inductor, this is your inductor having the length L. Okay, and area of one turn, area of this turn, this is a circular turn of radius R. So basically this is the solenoid. Okay, inductor is a type of solenoid. Okay, so this is a solenoid having a radius R, length L. So, and this is what, this is the circular coil of radius R. So area of this circular coil, we are taking pi r square, and L is the self inductance. Okay, you can say inductance. I have written all the things here. Small r, radius of the solenoid. L is the length of solenoid. Volume of the solenoid, volume is area into length. So this is your area, pi r square. You will multiply it with length, you will get the volume. Energy stored in an inductor, half Li square. Half Li square. This thing you should know. And what is the self inductance of the inductor? Self inductance of the inductor is this. We have derived, I think, in the last class. So Nafisa was absent, so you can go for the video lecture. Okay, or you can take the help of any book. So basically L will be mu naught n square pi r square L. So we will put this value here. And current, how we will calculate the current? Okay, so This is the current in the inductor or in the solenoid. Okay, so I will tell you how will I calculate the current. How will, so basically what you should know, what is the energy density, and you should write this also. What is the meaning of mu naught and small n? Energy density is energy stored in the solenoid or inductor divided by the volume. Okay. Now this is the energy stored. U is equal to half. What is L? L is mu naught n square. Mu naught n square pi r square into L. Okay. Now how I will calculate the current? We know that the magnetic field due to the solenoid is given by mu naught into small n into current in the solenoid. From here we can calculate the current. So current will be V divided by mu naught into n. Mu naught into n. So we will put the value of current here. Okay. So here we will get this V divided by mu naught into n. Now see, this n square will be cancelled out with this n, and this mu naught will be cancelled out with this mu naught. Okay. So you will have the energy. This is capital U. Okay. This will be half into small n into pi r square into L. Pi r square into L into magnetic field. This is your energy. This is your energy stored. Okay. Okay. So now energy density U small u. You will put this value half n into pi r square. N into pi r square. Actually, there is one more thing also. This is the current, na? This is the magnetic field due to the solenoid. Okay, and this is your n, na? This is your n. So okay, so this is your energy density, half n into pi r square into L into magnetic field. You will divide this with the volume. What is your volume? Pi r square into L. Okay, you will divide it with what I am doing. Just a minute. Actually, this is half. This is L. This is I square. Okay, so we have to take the square of this. We have to take the square of this. Okay, so basically it will become, see here, this energy stored in an inductor is half Li square, na? So this is half, this is your L. Okay, this is your L. I have taken L, this L, and I square is this. I have calculated from here. So this is right. Okay, no problem. I is equal to V divided by mu naught into N. Okay. So basically this is the square. So this will become mu naught square. So this will be cancelled out with this. Here will be mu naught. Okay. So I am writing once again. This will be your energy half. This mu naught will be cancelled out. So this will become, okay, mu naught will be cancelled out. here is n square and here is n square, so n square and n square will be cancel out. So here will be your pi r square into L, r square into L you have, and multiplied by what you have, magnetic field square. Okay, and there is 1 mu naught. Okay, here, because here is 1 mu naught, here is mu naught square. Okay, now energy density small u is equal to the capital U divided by the volume. Volume is V. Okay, so this is your capital U, half pi r square into L into V square by mu naught, and you will divide this with volume. What is volume? Pi r square into L. Okay, so pi r square and pi r square will be cancel out. This L and L will be cancel out. So energy density will be half of magnetic field square divided by mu naught. This will be your energy density. This small u is your energy density. Okay. In volume, we will take capital L. Okay, capital L here. Here also we will take capital L. Actually, capital L is already taken, so small l is okay. Here is small l, and here also will be small l. Here also will be small l. Otherwise, there will be confusion. Okay, so here also we will take a small l. Okay, note down. So first we have calculated the energy. Okay, after that we have calculated the volume, and energy divided by volume is energy density. Note down. And with this chapter is finished now. And there is one more topic, eddy current in this. So that is removed from your syllabus.
Sir, can you scroll? Yes, sir, finish.
Okay. So energy density is energy stored in an inductor per unit volume of the inductor. Means energy divided by volume is energy density. Matthew completed.
Yeah, sir, one second. Yeah, sir.
Okay, so that's all about the electromagnetic induction. So basically, in electromagnetic induction, we have discussed the electromagnetic induction. Change in the magnetic flux is very important for this electromagnetic induction. You should know how to calculate the flux, magnetic flux. You should know. Okay, and there are one formula, one law I have used in each and every topic. That is Faraday law. Faraday law of electromagnetic induction. Okay, so now we will start the alternating current. We will start alternating current. So basically, first thing is you should know what is the direct current before the alternating current. Okay, so this direct current, if you will plot a graph of current versus time, so you will see this current is constant with time. Means this current does not change the direction, does not change the direction with time. Okay, at different times the value of the current is same. Okay, and direction is also this is above the time axis, so you can say this is a positive direction. Okay, so direct current does not change with time, and the current by the battery or the cell, the current given by the battery or the cell is the direct current. Okay, Now alternating current. This is the chapter. This thing we will study in detail. Alternating current. So basically, alternating current is like this. Okay, this is the alternating current. So if you will draw a graph between current and time, so you can see at different value of time and at different value of the time, there is different value of current. Okay, suppose here the current is 0, and at some time here the current becomes maximum. Again, after certain time the current becomes 0. Okay, and here the current is, your alternating current is positive, here your alternating current is negative. So basically the direction as well as the magnitude of the alternating current is changing with time. Okay, changing with time. And alternating current is given by the AC generator. AC generator. So next topic is the AC generator or dynamo. So what is the AC generator? So mechanical energy is converted into the electrical energy. Okay, mechanical energy is converted into the electrical energy. So basically in AC generator, what happens? There is a coil, and that coil is rotated in a magnetic field. There is a given magnetic field, and there is a coil, and that coil is rotated in a magnetic field. Suppose this is the coil, and here is the uniform magnetic field, and this coil is rotating in a magnetic field. So due to the rotation of the magnetic field, there will be the current. Okay, so we will discuss this in detail. So first you should know what is the AC generator and what is the principle of AC generator. So as I have told you, Faraday law is very important. So this AC generator is based on the principle of electromagnetic induction. Okay, electromagnetic induction. So basically what happens in AC generator, there is one coil, and this coil is rotated in a given magnetic field. Suppose this is the magnetic field and this coil is rotated. Okay. This is a coil, rectangular coil. Suppose this is a rectangular coil, and this rectangular coil is placed in a magnetic field. Okay, so you should know what is happening here. We know that the area vector is perpendicular to the coil. Area vector is, when the coil will rotate like this, the direction of the area vector will change. The direction of the area vector will change. Okay, but the direction of the magnetic field is constant. Direction of the magnetic field is not changing. The magnetic field, suppose, is in this direction. Okay, and but when the coil is rotated, so direction of the area vector is changing. And theta, what is theta? Theta is the angle between the area vector and the magnetic field. So here, when the coil rotates, theta will change. So due to change in theta, magnetic flux will change. And I have told you, whenever the magnetic flux linked with the coil change, there will be an induced EMF. And due to that induced EMF, there will be the induced current in the AC generator. So it is based on the Faraday's law of electromagnetic induction, which says that whenever the magnetic flux linked with the coil is changed, EMF is induced in the coil. I have told you how the flux is changed linked with the coil. Okay. So in AC dynamo, flux is changed due to the rotation of the coil in the magnetic field. Okay, here this is your coil. This coil is rotated in the magnetic field. So here is this area vector. This is your area vector. So this, when the coil rotates, the area vector changes the direction. So this theta is changing. Okay, here your theta is variable. Theta changes. So due to change in theta, there will be change in the magnetic flux. What is magnetic flux? VA cos theta. So this theta is changing. Theta is changing means this cos theta is changing, means cos theta is changing means this phi is changing. And whenever there is change in phi, there will be induced EMF in the coil. Okay. So I have written. So this is the construction. This is the construction. Basically, in AC generator, there is coil. This coil is known as the armature. These are the field magnet, and these field magnets are used for the magnetic field. Okay, these magnets produces the magnetic field. So these lines are the magnetic field lines. Okay, so this coil is basically rotating in the given magnetic field. Okay, this is the coil and this is the axis about which the coil is rotated. So this is the axis of rotation. These are the field magnet. This is the armature. So what is omega? Omega is the angular velocity of the coil. Okay, so suppose n is the number of turns of the armature, a is the area of the armature, b is the strength of the magnetic field, omega is the angular velocity of the coil or armature. Basically here this thing is clear. Okay, now what is this? These are the slip rings. These are the slip rings, means these types of rings can slip on this. Okay, slip on this rod. Okay, and these are the brushes. Okay, so basically due to the rotation of the coil, the current is induced, and through this slip rings the current, and through this brush the current goes to the load. So basically we are able to get the current from the AC generator. Okay, okay, so now we will discuss the working. So magnetic flux linked with the coil. This is your coil, and I have told you the magnetic flux linked with coil is given by BA cos theta. And what is theta? Angle between the magnetic field and the area vector. And this theta is changing. Okay, because of the coil is rotating. And I have told you this omega is equal to theta by t. So theta can be written as omega t. So here we can write phi is equal to magnetic field is not changing, area of the coil is not changing, theta is changing. So theta we can write omega t. Theta is equal to omega t. So this is our magnetic flux. And according to the Faraday law, E is equal to minus d phi by dt. E is equal to d phi by dt. So this is dy dt of what is phi? VA cos omega t. Okay, VA cos omega t. So now we can differentiate this. So this VA is constant. This will be out of the differentiation. So now you can differentiate this cos omega t. So differentiation of cos omega t is sin omega t minus sin omega t. So when you will do dy dt of sin t, you will get cos t. When you will do dy dt of cos t, you will get minus of sin t. So we will put the value. This is minus VA and this is minus sin t, sin omega t. And in denominator, there will be omega. In numerator, there will be omega. Okay. So suppose you have dy dt of cos of 5t. So first you will differentiate this cos. This will become minus sin of 5t. And this 5 will be multiplied by this. Okay. So this will be the differentiation of sin 5t. Okay. Cos. Okay, now this VA and this is omega. So this will become VA omega and minus minus plus. So this will become sin omega t. Sin omega t. So basically this will be your induced EMF in the coil. This will be your induced EMF in the coil. Now, see, this EMF is in the form of the sine. This EMF is in the form of the sine. So sinusoidal variation of E means this EMF is varying according to the sine function. We have discussed in the starting. Okay, the sine function. This is the graph of the sine basically. Okay, so in this way, this is the variation of the current, the variation of the EMF or voltage will also be like this. Okay, so I have already written the drawn the graph also. Okay, so sinusoidal variation of E, we can get this from this. Okay, because in the function of the EMF there is sine. Okay, so for maximum value of EMF, for this EMF to be maximum, this value should be maximum, but this V is constant, area is constant, omega is constant. We cannot change this. We can change the sign omega t, and the maximum value of sine omega t is +1. Maximum value of sine omega t is +1. Okay, this thing you should know. +1 is the maximum value of sine omega t. Okay, maximum value of sine omega t. So if this is the coil, okay, and this coil has the n number of turns, so total EMF will be total EMF will be total EMF will be this EMF multiplied by n, so we will get total EMF. So this will become nba omega, okay, nba omega sine omega t, and for the maximum value of EMF, you will put sine omega t as 1, so you will get nba omega. Okay, here you will put sine omega t equal to 1. Okay, here you not here, because this is for 1 turn. For n turn, this is the EMF. Okay, so here you will put sine omega t as 1 for maximum EMF, so you will get nba omega. So now E max is nba omega. You can put this equation here. You will get E is equal to E max sine omega t. This will be your final equation. This will be your final equation of EMF. E is equal to E max sine omega t. What is the value of E max? nba omega. And this is the graph of EMF with time. Okay, so you can check the graph. At t is equal to 0, this sine becomes, this omega t will become 0. So you can say this is sine 0. So value of sine 0 is 0. So value of EMF is 0. Okay. And at pi, when you will put pi, so it will become sine also. At pi, the value of the sine is 0. Okay, so that is why here also the you will get the value of sine as the value of EMF as 0. And at this point, this is the value at pi by 2. Okay, so when this omega t will become pi by 2, so this EMF will become maximum. Okay, so this is the graph, and this capital T is the time period. And what is time period? Time taken by the coil to complete one rotation. So in one rotation, I have told you, in one rotation the coil will swept an angle of 2 pi. 2 pi means 360 degree. So from here to here, this is T, and is the time taken, and 0 is the angle, initial angle, and at time T, capital T, the angle becomes 2 pi. Okay, and at 2 pi, again the value of EMF will be 0. Okay, note down this. Completed. Matthew and Nafisa and Nawal.
Yeah.
Nafisa completed.
Yes, sir.
So write down this AC generator.
Sir, can you scroll up a little bit?
Okay.
Yes, sir. You can scroll down.
Okay. So basically, this is your coil. This is the direction of the magnetic field. This is the area vector of the coil. Okay. And I have told you area vector is always perpendicular to the plane of the coil. So when the coil will rotate, the direction of the area vector will change. Theta will change. Magnetic flux will change. And change in magnetic flux will produce EMF. And EMF will, due to the EMF, there will be the current. Should I scroll down?
Yes,
Nawal,
sir.
should
Yeah,
I
sir.
scroll down? Okay.
Yes, sir.
So in exam, if you will draw this, na, so I think you will get full marks. But you have to write all the things what is field magnet, where is the field magnet, and slip rings, brush, load, armature. This is the construction of, just a minute, construction of AC generator.
So you can scroll down.
Nafisa, should I scroll down?
Yes, sir. Yes, sir.
Okay, okay.
So you can go down.
Okay. So from 0 to t by 2, from 0 to t by 2, or you can say for 0 to pi angle, 0 to 180-degree angles, the EMF is positive. Okay, this is known as the half cycle. 0 to t by 2 is the half cycle, or 0 to pi is the half cycle, and 0 to t is full cycle. 0 to 2 pi is full cycle. And for completing one cycle, time taken by the coil is known as the time period. You can draw the graph like this. Sine. Completed, Matthew?
Yes, sir.
Okay, so you should know this equation of EMF. E is equal to E max sine omega t. And what is E max? And A B omega. This thing you should know. Okay, this equation you should know. And what is the maximum EMF induced? So we will solve one question. This question is from NCERT. So a man pedals a stationary bicycle. The pedal of bicycle are mm, the pedals of bicycle are attached to a 100 ton coil. What? 100 ton coil. So basically there is one coil having 100 tons. Number of tons 100. Area of that coil is this 0.10 meter square, and they are saying the coil rotates at half revolution per second. Okay, so number of revolution per second is frequency. Number of revolution per second is frequency. So they are saying frequency is half hertz. So the coil rotates half revolution per second. Okay, half revolution per second. This half revolution per second is the frequency is given, and it is placed in the magnetic field of 0.01 Tesla. Magnetic field of 0.01 Tesla, perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? So basically this is the case when your coil will rotate. This is the case when your coil will rotate. Means the okay. Here it is given, frequency is given, means the coil is rotating in a given magnetic field. But what happens when the coil rotates in a given magnetic field? EMF induced in the coil, and what is the maximum EMF induced? E max NA B into omega. Okay, so omega is also given by 2 pi into F. F is the frequency. So number of turn is 100, area is 0.10, multiplied by magnetic field 0.01. Omega is 2 pi, frequency is half. Okay, so your answer will be 0.314 volts. This will be the formula of the maximum EMF, and accordingly you will put all the values. Okay, note down this. Rest of the things we will discuss in the next class. So basically in the next class we will discuss the average value for half cycle, average value for full cycle. After that we will discuss the root mean square value of the current. Okay, and then after that we will start the circuit theory, AC circuits.